My name is Alessandro Fael Garcia. I'm a senior solutions engineer in the NGINX community analysis team. And I also happen to be the main/only internal developer for two of our most popular open source projects. One of them is the Docker NGINX unprivileged image, and the other one is the Ansible NGINX role. Guess a little housekeeping before I get started proper. You can find my contact details down there in the slide. I'm sure you have any questions after the session. Feel free, if I don't get to them here, feel free to shoot me an email, get in touch via Twitter or GitHub. And just to set expectations a little bit more, I don't think any of the lessons that I'm going to be covering here are necessarily going to be groundbreaking, but hopefully they confirm things that you're already doing in your pipelines nowadays, or they provide some guidance on how you could improve some of your workflows. And with that being said and done, let's move to the beginning, chapter 1, the great NGINX. So you probably already know what NGINX is, but just in case, just to level set expectation, a little bit of what NGINX is about, and just to people that might be actually tuning to the recording later down the line, let me give you all a brief recap about NGINX. NGINX is, it started as a web server in 2004. The main goal back when it was first created, or the problem it was trying to solve, was the world-famous C10K problem, which the Cliff Notes version of that problem is that no web server before NGINX could handle 10K concurrent connections. Then NGINX came along, and it was able to handle them. There's a little bit more nuance behind it, obviously, but I'm not going to delve into it right now. As of April 2023, it's the most used web server in the world. And in the almost 20 years since it first got created, it's been, a bunch of new features have been added these days. In addition to being able to use NGINX as a web server, you can use it as a reverse proxy, as an API gateway, as a content cache, as a CDN, as a WAF, and the list goes on. You can pretty much do everything with NGINX. Well, not everything, but you get the gist. And there's very, very good reason for its increasing performance. You could say that NGINX is the Formula 1 car of web servers. It has a very performant engine, hence the name NGINX. That's probably a joke. I actually don't know where the name came from. But it also has a very lightweight encasing. It's around 8 megabytes on Alpine Linux. If you're using other distributions, Debian, RHEL, whatever, it's not going to be 8 megabytes, but it's still pretty small. Combine those two things together, you get a blazingly fast web server. Well, reverse proxy API gateway, depends on how you want to use it. Moving on, chapter 2, tale of two GitHub projects. So now that you covered a little bit about NGINX, let me move on to the two projects that I'm going to be talking about today. The first one is the Docker NGINX unprivileged image. This project is fundamentally a port of the upstream Docker NGINX repository, which you'll probably have used at some stage in your life. And the only major difference, there's two main differences. The first one is that it obviously makes some changes to the Docker image to be able to run NGINX in an unprivileged environment. The second main difference is that it has its own pipeline to build and push those images. The upstream Docker NGINX repo is part of the official Docker library, so all the pipelines are maintained and supported by Docker. For various reasons that I'm not going to delve into here, the unprivileged image is not part of the official library, which means all the building, pushing, all the CD pipelines have to be run locally by, not by me, not locally, I guess, but they have to be integrated within the repo run by us, by NGINX. And then there's the Ansible NGINX role. She'll note there's a bunch of other NGINX roles out there, Ansible roles. There's one for configuring NGINX. There's one for NGINX App Protect, which is our commercial WAF offering. There's an Ansible collection for NGINX, a bunch of Ansible stuff out there. But all of the innovative, so to speak, or any of the new developments that get done into our CI/CD pipelines are usually first made on the main NGINX role, and then they get ported across all other roles and collections. Ansible, everyone I'm sure knows about Docker. Ansible, just in case you don't know, just TLDR, it's a configuration management tool. It's not that dissimilar from Puppet, who is here, for example, is one of the sponsors. And with that, let me move on to chapter 3, Moby Dick, or the Docker unprivileged NGINX image. I'm going to be covering now some of the lessons that I've learned. They were mostly in chronological order to when they were implemented, not always, but just to give you a little bit of a guidance on how things are going to be presented. And I'll start with the first lesson, which is to implement a CI/CD pipeline as soon as you can, not 4 years later, which is how long it took me to implement a CI/CD pipeline for the Docker NGINX unprivileged image. For the first 4 years, I was building everything locally using a local script. Needless to say, local scripts for CD are not great. This script took on average about 30 hours to run. On my laptop, every time I had to do a new release or new CVE came around and had to rebuild everything from scratch. It's not that common for a build script to last 30 hours, but it can last even longer than that. You don't want to have your local laptop or your local environment being set up to such a tremendous amount of effort for so long. Also, in this case, it took half of my laptop's RAM, basically made it unusable. Say your laptop crashes, or whatever many issues your local laptop can have will crash the script. You have to start again. Not fun times. And as it turns out, it probably took me longer to actually write this bash script than it took me to implement CI/CD in the first place on GitHub. So just as soon as you can, just implement your CI/CD pipelines, whether that's via GitHub Actions or whatever other tool out there that you want to use. Just make it one of your first priorities. Second lesson, figure out when to best publish new artifacts. That is especially relevant if you're pushing something like Docker images to an upstream repository. It also can apply to any amount of packages. There's some expectations or some unwritten rules around publishing packages. One of them, for example, is that you never publish something new on a Friday, because if things break, people are going to have to stay over the weekend. That's not fun. So it's up to you. You've got to figure out what makes the most sense for your project. For the Docker NGINX unprivileged project, what we ended up settling on that made the most sense is on a weekly basis, every Sunday night or Monday morning at midnight. I think it's CST. I think that's the default GitHub Actions timing or time zone. New packages, new Docker images are built and published to Docker Hub, to the GitHub Container Registry, and to the Amazon ECR registry. And then there's also the option, which is very neat, that GitHub lets you do, which is to set this flag called workflow dispatch, which lets you manually trigger those builds down the line, which, for example, if, say, it's Wednesday and someone finds there's a new CVE, and then there's a fix gets released for that CVE, and you want to publish that fix before next week, you can just go manually trigger that new build. Next lesson, integrate one delivery target at a time. If once it works, move on to the next target. This is what I did when I was implementing Docker Hub and the GitHub Container Registry and Amazon ECR. Even if you have the code done from the beginning and you're pretty sure it works, and you maybe test it in development and it works, when you're publishing it to production, it's just way better to still make sure that one target works at a time. You push your builds to Docker Hub, you give it a couple weeks, make sure that there's no fires to put out, then you implement, let's say, the GitHub Container Registry, wait another couple weeks, make sure there's no fires to put out, and then you go into the next step, and so on. This fundamentally helps you, if things go wrong, to just be able to address one issue at a time instead of having, 10 new issues over a week targeting 3 different platforms. The next lesson is that caching can be cool, but be wary of potential pitfalls. Why do I say this? When I first found out about caching in Docker, using GitHub Actions, for Docker images using GitHub Actions, I thought, this is cool. My builds now on average on GitHub Actions still take 4 or 5 hours. Let's try to make it a little bit, faster. It turns out that did work quite nicely. Actually, my build times went from 4 or 5 hours to 30 minutes, 20 minutes, 10 minutes sometimes. But I did not take into account that caching, the way it's implemented at least for Docker and GitHub Actions, it fundamentally does not detect package updates within your internal Docker file unless they're very explicitly said. So dependencies of dependencies and so on are not really flagged as being outdated. And what that means is that when an ECVE happened and a new fix was released, sometimes rebuilding the full image will not actually force the rebuild of the cache, and the CVEs will not get fixed. That can be a huge pain in the ass, to put it nicely. And there's also this small issue that the GitHub Actions cache to this day is not fully quite there yet where it should be. If you want to delete a cache, you have to go through the entries manually, delete them via TOX. If you want to use the GitHub CLI, it's a little bit better, but it's still a little bit of a process. So, caching can work out in your project, but before you implement caching, make sure that you're taking into account all the possible things that could go wrong with the cache, and be ready to potentially having to nuke certain caches and going through that process, which again, it's still not quite there yet. And the final and very obvious lesson that I've learned over time for the Docker NGINX Privilege repository is to never rewrite tags. I once upon a time decided to rewrite a little tag because I made a small change and I thought it was going to be a huge quality of life improvement for everyone using the repository and using the Docker image. Turns out people were not happy about it. And since then, obviously, I learned my lesson the hard way. You just never rewrite any tags, no matter how minor the changes. Doesn't matter if it's just a markdown update. People expect their tags, for good reason, obviously, gotta add, to be immutable, and they should be mutable. So yeah, no matter how tempted it might be, just don't do it. And with that, we can move on to chapter 4, from the Earth to the Ansible Galaxy, which is some of the lessons I've learned whilst developing the Ansible NGINX role. Ansible Galaxy, for those of you that might not know, is the Ansible Open Source marketplace. As the little joke. All right, lesson number 1, avoid pipeline vendor lock-in as much as possible. When I first started working on this project, the go-to default for Ansible workflows were both for CI and CD was Travis. It was the recommended tool by Ansible. It actually even came with some built-in integrations. As we all know by now, Travis open source is no longer a thing, for better or worse. So that's obviously not a good candidate for any open source project. So I had to migrate to GitHub Actions. You could fill in any other pipeline tool out there. GitHub Actions just made the most sense to me. And fundamentally, it was relatively easy for me, because all I was doing in Travis was a bunch of scripts. Porting scripts is easy, but you gotta be careful not to try to lock yourself too much with that pipeline. A good example, for example, if you're using GitHub Actions of how that can happen, is if your entire workflow depends on externally supported pipeline actions, and you're just using pipeline actions supported by other persons. If you want to migrate from that sometime down the line, it's gonna be quite hard. Which does not mean that you should not be using external GitHub Actions supported by other people. Just make sure it's a conscious decision and you know what you're doing when you choose to use one of those instead of your own scripts running on whatever platform. Lesson number 2, optimize your pipeline's runtime and efficiency. This is one of the most important things, honestly, this day and age, insofar as pipelines go, especially if it's part of your automated workflows. It just makes your life so much easier. Developer productivity goes up the roof. If there's an issue with your code, you're going to be able to find it as soon as you can. There's multiple ways to do it. There's no right or wrong way. For example, in my case, I used to run a bunch of molecule tests. Molecule is Ansible's native testing suite. But I used to run them in order in the same workflow. What that meant is that fundamentally running a full suite of tests could take easily about 8 hours, something like that. And that's when I learned about using build matrices. Travis supported them, so does GitHub Actions. I assume other tools that they support them too. You can create a workflow matrix, and then you just run a bunch of tests at the same time. Run like 10 jobs concurrently, and they will hopefully be done within an hour or two, instead of having to wait like 10 hours just to have a single test of suite of tests to run. Again, there's no right or wrong way to do this, but there's always some way you can optimize your runtimes. The next lesson is split your pipeline into distinct workflows. So when you're starting, this is a little bit like, monoliths versus microservices. When you're starting, having something in the same workflow file can ease development speed, might make sense, depending on your whole ecosystem infrastructure and the complexity of your project. But as you keep developing it, you keep adding more use cases to and things that your workflows can accomplish. It's a good idea to start splitting them into unique and distinct responsibilities. For example, in my case, I have one pipeline that's for testing, one pipeline that's for deploying new Ansible releases into Ansible Galaxy, and then I have one pipeline that's for creating release notes. And it could get even more deep than that. It could have like a pipeline that's for testing software, for testing PRs, and then for testing external and internal PRs, different pipelines. You could have a more complex pipeline that runs once a week and does like a full range of unit and integration tests versus a more simple pipeline for external PRs. But fundamentally, it depends on your use case. Again, just keep in mind that it's usually a good idea to, over time, split your pipeline into distinct workflows. And this actually ties into the other lesson. Figure out when it makes most sense to run each workflow. If it's a workflow that just publishes to, say, Ansible Galaxy, maybe you only need to run it when you're creating a new release. Maybe instead, if you have a pipeline that is creating a Docker build artifact, you want to publish it on, you want to run it on every external PR, publish it to a development environment, and test that it works. If you have a pipeline that only does release notes, maybe you only want to run it when you're doing release notes, and so on. Again, it depends, but you got to figure it out. It's a good idea to spend some time thinking about it. Next lesson, Dependabot is great, and you should enable it. This is very GitHub specific. Dependabot is a great tool. It will tell you exactly what packages you have updated. It will open PRs for you automatically. It will save you a lot of time that you will be spending otherwise if you were hunting for those updates yourself. There's a little issue with it, though, and that's that it can also be overwhelming. At least as of 2 years ago, things might have changed, but 2 years ago, the defaults meant that Dependabot will open a PR anytime a new release for any package got released. And sometimes, like in this series of PRs that I have here, basically results that over a week, maybe you have like 5, 6 PRs being opened at random times over different days. Suddenly, half your job becomes to be a Dependabot maintainer. So it's a good idea to use Dependabot, but tweak the updates to a consistent and same frequency. What I did, and what made the most sense to me, is that now every Monday, because Dependabot lets you do this, and not a lot of people know about it, but basically what it is, every Monday at midnight or Sunday night, Dependabot searches at the same time for any new updates. It opens a bunch of PRs, and then every Monday morning, when I log onto GitHub, I can see any PRs, deal with them all at once. If there's any issues with one of the PRs, I can deal with it over the week, and so on. But I only have to worry about Dependabot once a week, fundamentally. Right. Next lesson, hard-code package versions in all your pipelines. This is something that has bitten me quite a few times. It still does bite me to this day with some packages, like last week, just more recently. It's not uncommon, especially in some more dynamic ecosystems, such as Node or Python, to have multiple packages being released week after week. Those packages sometimes usually include a bunch of dependencies. Those dependencies, in turn, every once in a while might have breaking changes. It's not uncommon for your workflow to just randomly stop working from one day to another. That's again not great. It's not the first time that's happened to me that I've had to spend like a full day just trying to debug why my pipeline stopped working, only to eventually find out the issue was that one of my dependencies got a major breaking change over an overnight update, and I did not realize. Hard-coding those package versions helps with that. You will always know what version is being used, and if there's any update to that package, It'll be found by Dependabot. Dependabot will open a PR, and you'll be able to fix the issue in that Dependabot PR specifically, instead of your whole pipeline failing. The next lesson is that pipelines will randomly fail, and it's good to find ways to avoid a hard restart. Why do I say it will randomly fail? If you're using anything that relies on a potential HTTP endpoint, whether that's downloading a package from somewhere or querying an API, timeouts happen, the internet goes out, there's always a chance that something will randomly fail if you use networking or anything like that in any way or shape. You'll know what I mean. There's by default, GitHub has this option, GitHub Actions has this option called fail. I can read it from my side. Fail star, fail safe? Fast fail, something like that. It's set to true. That means that if one of your jobs in your matrix fails, everything will fail automatically. I'm not a big fan of that because, again, pipelines randomly fail. I always suggest people to set it to false so that if one of the jobs fails, all the other jobs will still continue. And ideally, if it was just a random failure, all the other jobs will succeed. Then you can go to the job that failed, dig into it, see why it failed. If the issue is something to do with your code, obviously you go fix it and push the new commit. But if it's just a random failure, which happens it happens more than half the time. It happens more frequently than it does not. You can just rerun the job that failed. The next lesson, very briefly, it's only something that you develop over time. It's just whenever possible, consolidate pipeline tools and steps. To do this properly, you usually have to keep actively checking for updates on the tools that you're using. An example for this, for example, is one of the Ansible lint updates that came out in the past couple of years. Added YAML lint as a dependency and started running YAML lint natively within Ansible lint. What this means is that, what this meant is that I was fundamentally able to get rid of YAML lint in my workflows and have Ansible lint deal with that. It's not a big time saving, but over time, if a bunch of these little changes happen to some of the tools you're using, you're going to be saving some time, and it goes back to optimizing your workflows, be able to run the workflows as fast as you can, as often as you can. There's also, beyond that, there's also just as you keep developing your workflows, the more you learn how your software works and how the workflows work, there's always opportunities to optimize some of those workflows a little bit more and consolidate steps, probably. Next lesson is enabling contributors to develop PRs for licensed software. I'm not going to delve too much into this because it's one of those, there's no right or wrong ways, and it depends on your use case. But fundamentally, if your tool has an open source component and maybe an enterprise component like NGINX Docker, NGINX Open Source, and NGINX Plus, it's a good idea to let users have a way to test those those enterprise features by letting them have an option to, if they fork the repo, provide some licenses, some secrets, be able to test that software. Instead of doing what I initially did here, which was to fundamentally block any enterprise tests from running on any fork or external PR. And the last major lesson is integrate all deployment target distros in your pipeline, as well as your target architectures. Now, this seems like it makes a lot of sense, but I've seen a bunch of times where people don't properly test all the platforms that are that their software is supposed to target, or they don't test properly all the architectures that their software is supposed to be running in. It's very obvious, it just saves you a lot of headaches. Even if you test some of these things locally and they're not part of your pipeline, and you think you're going to be doing locally every major release, it's only a matter of time until something slips and you stop doing that. So just integrate everything in your pipeline, in your automated pipelines, really. And with that, for the final few minutes, we can move on to Chapter 5, 100 Years of Collaboration, also known as why pipeline as code is great. Pros and cons, fundamentally. So there's the good. There's the version control side of things when you're using pipeline as code, CI/CD as code. Version control, everything is checked into Git or Mercurial or whatever tool you're using. I would hope most people are using Git these days. You have automated PR well, not necessarily only PR, automated CI/CD is very easy if you use pipeline as code. You can foster continuous improvements by knowledge sharing between amongst other open source users out there in the world. You can reduce false positive bug reports. This says a little bit into the whole, make sure that you hard code all your package dependencies and whatnot. It helps people know if the issue is an issue on their end. Maybe they're using some packages that are not the package versions that they're not the versions they should be using. Or whether it's an issue with the source code, it's an actual bug. It also helps because people can then look at your CI/CD, be like, hey, this is being tested this way. Maybe I'm not using the software or the tool the right way. Maybe there's this flag or something that's not documented, but it's in the CI/CD pipeline. It does help quite a bit with that. And then the last part is both the source code and the CI/CD code live together. This is quite important because as a user, as an open source user, I know, for example, I myself love when all things are in the same place where I don't have to navigate through 3 different websites to find everything related to the software I'm using. So it's the same way why you probably would want to have docs in your repo, in your source code too. Just makes the life of external developers, and internal developers too, all the much easier. Then there's the bad, which is not necessarily bad, it's just things you need to think about. What do you do with secrets? If it's an open source project and it requires secrets to run, do you enable them for external PRs? If not, do you provide an easy way for external PRs to access your secrets? It's stuff that you need to think about. There's no right or wrong answer. Again, it depends on your use case, but you need to consider it. Then there's when do you run your CD pipeline, or for example, who triggers the CD pipeline. Does the CD pipeline get run on every PR? Get pushed to development repository? Does the CD pipeline only get run on new release? Is the CD pipeline automatically triggered? Do you need like a maintainer to come along and run the CD pipeline? All food for thought. But it's not necessarily bad, it's just the things that you really need to keep into account. And then there's the ugly, which is the cons. There's really no cons that I can think of or that I've ever really been able to find with pipeline as code. There might be some, I don't know. If there are, just hit me after the session and I will make some amends, but just no bad reason to start your journey with pipeline as code. And with that, that's the end. You can find those details in the slides later. I'm not gonna spend too much time here. But so we have a Twitter account, YouTube account with a bunch of videos, LinkedIn, whatever. And then there's the little epilogue, which is basically the Q&A. But before, I think I have like 2 minutes for questions, not a lot of time. I just wanted to do a quick call to action. We have an NGINX community Slack. It's quite recent, only like 2 months, 3 months old, maybe a little bit older than that, no longer than half a year old. But we are all hanging out there. It's been growing quite steadily in population. If you have any questions, if you want to interact with any of us NGINXers out there in the world, this is a great place to do it. And there's a QR code there, there's the link down. Then there's my contact details again, if you want to reach out at some stage. And I don't know if we have time for questions, but if you do, does anyone have any questions by any chance? No? Yes?
Did you find a way to test your GitHub Actions-based pipeline without running it in GitHub Actions?
Yes, there's a tool called ACT. It's a little bit of it's not the easiest tool to use. It has its quirks, but it does the job good enough.
I have a question regarding this case study. Is the public one? Can it be referenced?
The sites? Yeah, there should be on my, if you look at my session profile thing on Sketch app, whatever, I uploaded my slides. There should be a way for you to get access to them. I honestly don't know how that works, because I've never done it, but there should be a way.
Yeah, I'm asking for a publication, so if you have...
Oh, for a publication. That's maybe a little bit more involved. Just say around later, or you can shoot me an email or something, and we can look about it. Yeah. Right, one more question.
Have you done any experiments with build-X?
Yes, I actually do use that for all my Docker builds. Okay, yeah. Yeah, I should mention Docker. I built for all sorts of architectures using Docker. I use Docker Kimu now on GitHub Actions. I don't know. Anyways, way back when I did use Docker buildx natively on my GitHub when I run the scripts locally, and when these days, by default, if you use the Docker build action on GitHub Actions, it does use buildx behind the scenes.
And you mentioned QEMU, so you are supporting exotic architectures like
Yeah.
S390,
Yeah.
RPC,
Yeah. I do that for the Docker NGINX images. They're built for all the architectures. The Ansible role gets tested on AMD, ARM64, and S39X, actually. S390X. That's the names they come up with these days. All right. Any more questions? No? I think that's it then. Thank you for coming along.